Okay, so members, today I'm going to see how do we differentiate such functions when we have a function and a power. Here, the best way to go is to use natural logarithm. What is the natural logarithm? We have seen how we differentiate using natural logarithm. So, if I'm to handle this, you say, if I'm to handle now one, you can easily say, let y be this. So you say, let y be x power x. Now, your task is to lower this function here. So if that's your function now, I'm going to say to lower it, you introduce natural log. So natural log of y will be now natural log of x power x, which will be now x natural log of x when you lower it. So that's your natural log of y, x natural log of x. Now there you differentiate. When you differentiate this one, you say you get 1 over y dy dx. Then here you see it's a product of two functions, so then we use product rule. We say fix this, then differentiate this 1 over x, then plus fix natural log of x, then differentiate x, you get 1. So my dy dx will be, the whole of this is 1 plus natural log of x, then times y. But my y from here is this, which would be now natural log. So therefore, natural log 1 plus natural log of x, then my y, which is x, y. So now meaning, when I differentiate this, I remove this y, giving me now x power x, then 1 is natural log of x. So that's how we handle that. If I come now to number 2, still I say, number part B, I say, let y be now natural log of 1, let it be, let y be, which is 1 plus 3x over 1 minus 4x. So from there, members, now we introduce natural log. So natural log of y will be natural log of 1 plus 3x over 1 minus 4x. Now here, you can use quotient rule, but there, it's a bit lengthy. That's why we introduce natural log, so that we can use the properties. So if it's dividing, it's the same as subtracting these two. So natural log of y here will be natural log of 1 plus 3x, then minus natural log of this in the denominator. Then here you can differentiate. This one, this I get 1 over y, but I'm differentiating the function of y. When differentiate this, you say, when differentiate the order of this, you get 3 over the function. Then minus, when you differentiate the order of this function here, when you differentiate this, you get 0, and differentiate this, you get negative 4 over the original function, 1 minus 4x. So there, you can see that you can cross multiply. So my 1 dy dx is going to be, when I cross multiply, we are having 3 into 1 minus 4x. Then this one I think is going to give me a plus 4. When I cross multiply this here, 1 plus 3x. The whole over, when I multiply this, I get 1 plus 3x, then times 1 minus 4x. But then I multiply this y this side. So the whole of that times y. So let us see, this would be 3 minus 12x plus 4 plus 12x. The whole over 1 plus 3, 1 minus 4x. So from there now, members, I multiply it with my y. My y was, from here is that my y was this, so times 1 plus 3x over 1 minus 4x. So that this will cancel with this will cancel with this. So your dx of your y was 1 plus 3x over 1 minus 4x will be equal to 2. Here when with 7, 3 plus this, then over this and this. 1 minus 4x squared. So that's how we handle that one. Now I think you can handle this one because this y, let me do it side somewhere here. You say let your y be. That one, the square root is going to be 1 plus x power half because of the square root. Then over 1 minus x power half. Then you introduce natural log. This power will lower down and so on. When you come now, part B. Part B, there are many ways you can handle part B. This part B, you can still let y be your log 5 base 5 of x plus 3 over x plus 5. Now, there are two ways. You can choose to take 5 when you apply that property of logarithm, which says that log, let me write it here, log is c, then this is the same as a equal to b power c. So now this will be 5 power y equaling to now 2 x plus 3 over x plus 5. Then introduce natural log. So natural log 5y equal to natural log of. So you lower this power, so you have now y natural log 5 equaling, you apply properties of logarithms plus 5. So now we differentiate, you know that this is a constant. So you treat it as a constant, so when I differentiate this I get 1, but I'm differentiating the function of y. So natural log of 5, then y dx, because I'm differentiating y, equaling to, when I differentiate all of this, I get 1 over x plus 3, then minus, when I differentiate this I get, when I differentiate all of this I get 1, because this one, when I differentiate this I get 1, when I differentiate this I get 0. So 1 over x plus 5. So from here, we just simplify. So we cross multiply like this. We shall be adding now this and this, x plus 5, then minus this x plus 3, the whole over x plus 3, x plus 5. And now we see, now my b dx, my y was log x plus 3 over x plus 5 base 5 will be now this x will cancel, so I'll be adding 2 over x plus 3 x plus 5. So that's what we have members. So that's how we use natural logarithm to simplify life. I wish you the best. Please complete this one, and also complete. But this one, natural logarithm was already there. So this one will just expand and we appreciate. I wish you the best.